Okay, so we've already explored the quadratic function using our graphing calculator and looked at what we saw in vertex form. So we looked at the relationship between the parent graph y equals x squared and vertex form of a parabola right here where we have the a, the h, and the k. Now, with parabolas, with quadratic functions, we have multiple forms for the equations. And I'm going to get our parent graph on here. So vertex at 0, 0, and then we have points at 1, 1, and 1, negative 1, 2, 4, and negative 2, 4. So here's our parent graph. So the general form, which you talked about in Algebra 1, is right up here, y equals ax squared plus bx plus c. So we've got some general things that you should know about that particular form. Obviously the shape, it's still a parabola. Anytime you see the highest exponent as a 2, that means the degree is 2, that's going to be quadratic, it's going to graph as a parabola. If a is bigger than 0, or if it's positive, it's going to open up. You discover that with the a value when it was in vertex form on your exploration activity. If a is less than 0, then it is going to open down. Now the width is just like what we studied with parent graphs in absolute value. If the absolute value of a is less than 1, so that means we're not looking at the sign of a, just the number itself without its sign. If that is less than 1, then it's going to be wider than the parent graph. So 1/2, 2/3, those will all be wider than the parent. Narrower if the absolute value of a is bigger than 1. So if a is 2 or 5, it's going to be narrower. Now, because this general form, we can't see an h and a k like we could in vertex form, we have to be able to find the vertex another way. The way that we do that is by using this formula. The x-coordinate of the vertex is going to be the opposite of b divided by 2a. The reason I say opposite instead of negative is because if the b is negative, you have to make it positive. So it's opposite of b divided by 2a. That gets you the x-coordinate. To find the y-coordinate, you have to plug the x-coordinate in. So there's no formula to find the y-coordinate. It's just once you know the x, you plug it in to find the y. Axis of symmetry, going down the center, it always goes through the x-coordinate of the vertex. So whenever you find that x-coordinate of the vertex, just make it an x equals line to get your axis of symmetry. So we are going to go ahead and look at being able to graph the function and labeling the vertex and axis of symmetry, filling in all the information that is appropriate. You can see up here, we're going to graph them by hand today. We're not looking at our graphing calculator. And we can be able to determine the vertex, direction, axis of symmetry, domain, range, y-intercept of all of these quadratic functions. So first one we're looking at is in the general form right here, y equals ax squared plus bx plus c. So I'm just going to go ahead and label. My a is 1/2. My b here is -1. And my c is -6. So that's going to help me because I need to find my x-coordinate of the vertex. So I'm going to do opposite of b over 2a. So the opposite of -1 over 2 times 1/2. So the opposite of -1 is +1. 2 times 1/2 is 1. So the x-coordinate of my vertex here is 1. To find the y-coordinate, I have to plug in the x-coordinate. So I'm going to do 1/2 times 1 squared minus 1 minus 6. So that gives me 1/2 minus 1 minus 6. So 1/2 minus 1 is -1/2. Take away another 6 is -6.5, which as an improper fraction would be -13/2. Please do not use decimals. We've talked about this a lot of times. Unless there's already a decimal in the original, or unless it's a word problem, you should be listing your answers in simplest fraction form. All right, well, that should be the hardest part, is finding the vertex. The rest of it should be relatively easy. We need to make a t-chart, which you've done a million times in Algebra 1, to find some other points to plot. Now, we know that the parabolas are going to be symmetric around the vertex. So once you have the vertex, you can pick the points just above and just below. So if I pick 2 is just above 1, and then I pick just below 1 at 0. So 0 is easy to plug in. When x is 0, I have 1/2 times 0 minus 6. So -6 would be my y-coordinate. 2, when I plug that in, I'll do the work down here. 1/2 times 2 squared, which is 4, minus 2 minus 6. Half of 4 is 2. So I get -6. You should remember from Algebra 1 that if they're the same distance away from the vertex, which these ones are, they're both 1 unit away, that you should have the matching up in the y-coordinates. Now, if I go to pick the next numbers, -1 and +3, when I plug those in, those are going to give me fractions, which is fine. You can plot fractions if you want. I prefer not to deal with fractions, so when I get a fraction other than the vertex, because you can't help that, I then just skip on to the next integer. So I would try -2 and +4. So if I try -2, I've got 1/2, -2 squared is 4, minus -2, which becomes a plus, and then -6. So half of 4 is 2, 2 plus 2 is 4, 4 minus 6 is -2. Now, if I've done this correctly, when I plug in 4, I should get -2 because they need to match there. So when I plug in 4, I've got 1/2 of 4 squared, which is 16, minus 4 minus 6. So half of 16 is 8. 8 minus 4 is 4, minus 6 is -2. So it worked out. I'm feeling pretty confident about my points, so I'm going to go ahead and graph them. So -2, -2, 0, -6, 1, -6.5, so that's just barely below our coordinate plane there. 2, -6, and then 4, -2. So that gives us a pretty good idea of the width and shape. We can draw it. Axis of symmetry should be easy to fill in. It's always an x equals line, and it's always x equals whatever the x coordinate of the vertex is. The direction here is obviously up. The y-intercept, that's where it crosses the y-axis. So when x is 0, you can see that here, y-intercept is right here, y is -6. So 0, -6 is your y-intercept. The width, you need to go back and look at your a value. 1/2 is less than 1, so that means that this one is going to be wider. Domain means what x values do you see? Well, x can be anything because I've got these arrows going everywhere, so my domain is all reals. My range, my y values start at the vertex, so at -13/2 is my starting point, and these ones get bigger, so it's all reals greater than or equal to. So that is how we deal with our standard form, and those ones are actually the hardest. The other ones are easier. If you look at B, that's going back to vertex form here, which is what we experimented with yesterday. So here's the two key points there, but hopefully you remember most of it from yesterday. So this one is nice because I should know where the vertex is. Here's my x coordinate, changing the sign, and here's my y coordinate. So my vertex is at +1, 3. So no opposite of b over 2a to have to do. I can make my t-chart. So I'm going to go up and down 1. So if I plug in 2, I've got I'll do the work down here. 2 times 2 minus 1 squared plus 3. 2 minus 1 squared is just 1. 2 plus 3 is 5. When I plug in 0, 0 minus 1 is negative 1. Squared is 1. So that also gives me 5. If I go to the next ones, negative 1 and 3, if I plug in 3, 3 minus 1 is 2. 2 squared is 4. So I've got 2 times 4 plus 3, which is 11. I get the same thing when I plug in negative 1. So here you can count by twos if you want, as long as you have at least 3 to plot. I need 5 in the T-chart, but if you have at least 3 to plot, that's usually enough. Down here, it kind of wouldn't give you a very good width perspective. So in some cases, it may be better to just count by twos. But over here, we'll just graph these 3. So we've got 0, 5, 1, 3, and 2, 5. So make sure our bottom is rounded. Don't make them look like absolute value graphs. Axis of symmetry, always x equals whatever the x coordinate of the vertex is. So in this case, x equals 1. Again, this one also opens up the y-intercept. It's right here. When x is 0, y is 5. It's where it crosses the y-axis. The width, this one, my a value is 2. 2 is bigger than 1, so this one is narrower. My domain, x can be anything, so all reals. My range, my y values, they start here at the vertex. The y value there is 3, and they are getting bigger. So all reals greater than or equal to 3. All right, so we've talked about our general form. We've talked about vertex form. Lastly, we're going to talk about intercept form. And this is when you have it kind of looks like factored form. You've got x plus or minus a number times x plus or minus another number, and then an a plain number out in front. Intercept form is great because you can quickly see 2 additional points other than the vertex. The 2 x-intercepts are at P0 and Q0. Notice that we changed the sign because that parentheses we treat like bars. Remember that when you see your x in the bar, you have to do the opposite. So we're going to change the sign here to get the 2 x-intercepts. This is really important. The axis of symmetry, which is also the x-coordinate of the vertex, is halfway between the intercepts. So that means to find the vertex, you're going to do P plus Q and divide it by 2, because halfway between means you're taking the average. So P plus Q divided by 2 is going to give you your x-coordinate of the vertex. To find the y, just like with general form, you're going to plug it in. So let's take a look at what that should look like down here. Now, you'll notice if I'm looking at this form, I picked this one for a reason, it doesn't have 2 parentheses. That doesn't mean that this isn't in the right form. This right here, this plain x, is your x minus p, because that's like saying x minus 0 if nothing else is there. So, looking at those 2, and I should have added down here, on these vertex form ones, it will ask you for the x-intercepts, so we should add that there. So the x-intercepts, again, when you're inside the bar and you see your x, you do the opposite. So x-intercepts at when x is 0 and when x is negative or positive 4. I just told you to do the opposite, and then I almost didn't. So that means it crosses the x-axis at 0 and 4. So And if you want to list them as ordered pairs, that'd be 0, 0, and 4, 0, because if they're x-intercepts, that means they're on the axis. So 0, 0, and 4, 0. The x-coordinate of the vertex, you take those two x-intercepts, 0 and 4, add them together and divide by 2. So the x-coordinate of the vertex is going to be at 2. I have to plug it in to find the y-coordinate. So y equals 2 times 2 times 2 minus 4. So 2 times 2 is 4. 2 minus 4 is negative 2. So that's going to give me eight. Oops. And I think on yours I think I had the 2 negative, and on mine, when I changed it, it's not. So I'm going to change it to match yours, so that's going to change this here. Sorry about that. So that'd be negative 2 times 2. I was wondering why it wasn't matching up with my key. So that'd be negative 4, which would give me a positive 8. So 2, 8 would be my vertex. And I shouldn't have plotted that already because I'm going to need to count by 2's. So if I count by 2's here, I'm going to make it in blue instead of red. I've still got 0, 0, but 4, 0 will actually be here, and 2, 8, if I'm counting by 2's on this axis as well, would be right here. So there's 2, 8. There's my two x-intercepts. Now that I've changed this to match yours as negative 2, axis of symmetry is going to be x equals 2. The direction, now that this is negative, this one's going to open down. So when I connect it, it looks like this. The y-intercept is 0, 0. That's where it crosses the y-axis right here. The width, I'm sure you can tell by looking at it, but just in case not, that is narrower. Remember, we're not looking at the sign of A. Yes, A is negative 2, but it's not the sign, it's just the value, and 2 is bigger than 1, so narrower. Domain, X can be anything, it's all reals. Range, here's my first Y value, and they are getting smaller. So 8 is the value, but it's less than or equal to. So all reals less than or equal to 8. All right, so hopefully that allows you to use all three various forms to graph quadratics by hand. On Vertex or Intercept form, you'll notice that we didn't do a t-chart because we already have 3 points. The x-intercepts are 2 of them, and then my vertex is the third. So you don't need a t-chart for the Intercept form. All right, this next one should be super easy. I put a little note on yours that this is review from Algebra 1, and some may call this FOIL. If it's just asking you to write it in standard form when you're given intercept or vertex form, that just means multiply it out. So FOIL, remember, stands for first, outside, inside, last. So if I'm going to FOIL these two right here, x plus 1 times x minus 5, the firsts, x times x is x squared. Outsides, x times negative 5 is negative 5x. Insides is plus x. And lasts, 1 times negative 5 is negative 5. So please, please, please combine your like terms inside the parentheses first before you distribute. That will save you so much time because then otherwise you've got extra terms that you don't need. So combine the like terms first, then distribute your negative 3. So I've got negative 3x squared plus 12x plus 15, and that is my standard form. You go ahead and do B yourself. Remember that square means to multiply it by itself, so pause it and then come back to see if you get it right. All right, so order of operations says I have to do the squaring first. Remember that that means x plus 2 times x plus 2. So I'm going to do that part first. So firsts are x squared, outsides are 2x, insides are 2x, and lasts are 4. Next in order of operations comes multiplication. I'm going to combine those like terms in the middle before I distribute. So now I'm going to distribute my 1/2. So that's going to give me 1/2 x squared plus 2x plus 2 minus 3. And so when I combine these like terms here on the end, I've got 1/2 x squared plus 2x minus 1. All right, last one. Suppose a group of high school students conducted an experiment to determine the number of hours of study that leads to the highest score on the final exam. The exam score y for each student who studied for x hours can be modeled by this lovely quadratic equation. Which amount of studying produced the highest score on the exam? What is the highest score that the model predicts? Now, you could, if you wanted to, graph this on your graphing calculator to see what it looked like, but because this is in standard form and you can see that your a value is right here, you know that this is a parabola that is going to open down because the a is negative. So if you're looking at that and it tells you right in here that x is number of hours studied, the exam score is y. Look at that in comparison to what it asks for. What amount of studying produced the highest score? Highest score means highest y. The highest y value is going to be at the vertex. So, all this is really asking me for is to find the vertex. So, we don't need a lot of information. You don't need an exact graph. All you need is opposite of b over 2a. So, opposite of b would be negative 17.48 over 2 times negative 0.853. So, you can use a calculator to get that answer. You should get about 10.246. Now, that's the x-coordinate of the vertex. If we want to find the y-coordinate of the vertex, we need to plug that in. Again, please feel free to use your calculator to help you with these decimals. But if you're plugging this in for x, it should look like this. And use your calculator to plug it all in. You should get approximately 96. This, we're going to round because look at what the question is asking. It's saying which amount of studying produced the highest score. So that's hours. You're not going to say 10.246 hours. You're going to say about 10 hours. So that's part of the answer. And then it says, what is the highest score that the model predicts? So 96 is the highest score, would be your other answer. All right, hopefully you feel comfortable graphing by hand. That is it for today.